presentation to you, and it is devoted to the nervous center's functions. And the first figure is devoted to the localization of the different centers in the central nervous system and their role in the regulation of the different functions of the in the body. First of all, this is the reflex arch of the somatic nervous system. It starts every time at the stimulation. This is the stimulation of the skin. SK, this is the skin. This is the receptors in the skin. What are these receptors? This is the touch receptors, the temperature receptors, and painful receptors. The excitation conducts to the direction of the spinal cord with the afferent nerve fibers, and the first neuron is localized in the spinal ganglion between the projections of the vertebrae. This is the dendrite, this is the axon. This neurons is known pseudo-unipolar neuron. Then the excitation through the dorsal horn, through the dorsal root, passes to the gray substance of the spinal cord and make the transmission with the synapses to the sensitive neuron. The sensitive neuron is located in the dorsal horn. Then the excitation conducts. It conducts with the help of some neurons. It may be 2, 3, or more neurons, or maybe the excitation conducts directly from the sensitive neuron to the motor neuron, and the motor neuron innervates the skeletal muscle. The different skeletal muscles and the movement starts of the extremities. The movement starts of the extremities. This is the simple plan of the somatic nervous system. At the same time, these neurons, they are known alpha motor neurons, motor neurons, alpha motor neurons. This is the alpha motor neurons. This is the localization. They are regulated with the help of the motor cortex. The motor cortex is localized in the precentral gyrus, and this is the pyramidal tract. Pyramidal tract, you see the red color, and the right hemisphere of the cerebral cortex innervate the left part of the body, and the left hemisphere innervate the right part of the body. We have the cross of two pyramidal tracts at the level of the medulla oblongata. At this point, I present to you the sympathetic and the parasympathetic nervous system. The sympathetic and the parasympathetic nervous system, this is the main two divisions of the autonomic nervous system, and they have the afferent part, but not from the skin, but afferent nerves starts from the different viscera, from the bronchi, heart, gastrointestinal tract. At this plan, I present to you only the structure of the efferent part from the central nervous system to the viscera. This is like the example. This is the heart with 4 chambers, 2 atria and 2 ventricles. And this is the structure of the sympathetic nervous system. The neurons are localized in the 12 thoracic segments and forms the side cones. This is a lot of these neurons, but the afferent nerve fibers go out from the spinal cord, not directly to the side, from the ventral horn and the then it has the transmission in the paravertebral sympathetic chain. Near the vertebral, the vertebrum, this is the two chains, paravertebral chains. And pre-ganglionic nerve fibers are short, and the post-ganglionic nerve fibers are long, and the sympathetic nervous system innervate all the heart, all the chambers of the heart, and regulate the activity of the contraction of the heart and the automaticity of the heart, the rate of the contraction of the heart beats. And the same way, the sympathetic nervous system innervate all the other viscera, bronchi, stomach, intestine, spleen, and so on. And this is the parasympathetic nervous system, the main nerve of the parasympathetic nervous system. This is the two vagus nerves. At this plan, you see only one nerve. The center is localized in the medulla oblongata. This is the medulla oblongata, above the spinal cord. And the parasympathetic nervous system has the prolonged nerve fibers, and it has the transmission in the intramural ganglions. What is the intramural? What is the word? Intramural. Mura, at the Latin language, this is the wall in English. That's why they are located in the wall of the viscera, in the heart, in the stomach, and so on. This is the very short postganglionic nerve fibers. That's why the difference between the sympathetic, parasympathetic nervous system and somatic nervous system, that the afferent nerve parts in the somatic nervous system has no the ganglions. In the autonomic nervous system, there are ganglions. And the ganglions of the sympathetic nervous system is near the vertebral, near the spinal cord, but the ganglions with synapses are located in the viscera, the ganglions of the parasympathetic nervous system. You see, this is some very important nerve centers in the medulla oblongata. This is the vascular motor center, vascular motor center. This is the point, red point. This is the vascular motor center. It regulates the activity of the heart and the tone of the blood vessels. With the help of this regulation, the blood pressure may be increased or decreased. At the same time, this is the localization of the respiratory center. Respiratory center regulates the external respiration, the movement of the diaphragm with the help of the diaphragmatic nerves, and the movement of the ribs with the help of the innervation with the intercostal muscles nerves and the ribs nerves. At the same time, in this part, this is the localization of the vestibular nucleus. Vestibular nucleus regulates the muscle tone with the reticular formation. In all parts of the brain stem, the reticular formation is localized. The reticular formation has a lot of the neurons, and it is located in the medulla oblongata, in the pons, and in the midbrain. It regulates the activity of the spinal cord, at the same time the activity of the cortex and subcortical nuclei. In the pons, this is the pons, between this and that line, the very important pneumatoxical center is situated. And the pneumatoxical center works at the same time with the respiratory center. The pneumatoxical center help respiratory center to regulate the activity of the external respiration. If we destroy the pneumatoxical center, the respiratory center will continue regulate the external respiration, but the rhythm will be not regular, prolonged inspiration and a very short expiration, or maybe the pauses between the inspiration and the expiration. This is the localization above the pons. This is the localization of the midbrain. The midbrain contains a very important nucleus, red nucleus, two red nucleus, left and right, and the superior and inferior colliculi. On the back surface of the midbrain, this is the four hills. The upper colliculi or superior colliculi, this is the subcortical center of vision. And inferior colliculi or posterior colliculi, this is the subcortical acoustical center, subcortical, not cortical, but subcortical acoustical center. They may involuntarily regulate the process of vision and the accepting of the hearing information. Above the midbrain, the diencephalon, you see, this is the diencephalon, this is the localization of the diencephalon, and it includes the thalamus. The thalamus help to conduct the information from the spinal cord to the cortex, to the different parts of the sensor cortex. The hypothalamus, you know from the previous information, help to regulate the hormonal, it ensures the hormonal control. In the hypothalamus, not in all neurons, but in the some nerve centers of the hypothalamus, the special releasing hormones are secreted. And these hormones, liberins and statins, regulates the anterior lobe of the pituitary gland or the hypophysis. The posterior lobe synthesizes the two very important hormones. This is the oxytocin and vasopressin. And these hormones runs to the posterior lobe of the pituitary gland and then will be secreted in the blood. In the telencephalon, above the, additional, very important, that in the diencephalon, this is the localization of the epiphysis. This is not the nerve center. This is the endocrine gland. And epiphysis secretes the three hormones. This is the melatonin. The 70% of the melatonin is secreted during the night sleep. It ensures the night sleep. This is one very important reason of the beginning of the night sleep. And serotonin. The serotonin is secreted during the daytime, and it is reversely proportion, this secretion, to the melatonin. And the third hormone, this is the adrenoglomerulotropin hormone, which help to regulate the formation of the urine in the kidneys. Above the diencephalon, this is the telencephalon. It consists of the cerebral cortex. You see these only two examples of the cerebral cortex. This is the sensor cortex in the postcentral gyrus. This is a lot of the localization of the sensor cortex in the hemispheres. But at this picture, we see only the sensitive cortex. It receives the information from the skin. This is the touch receptors through the thalamus goes to the posterior sensitive cortex, painful reception and temperature reception. But this is the motor cortex. This is the sensitive cortex. The second part, this is the motor cortex. It is located in the precentral gyrus, and with the help of the pyramidal tract, it regulates the activity of the alpha motor neurons and voluntary regulation of the extremities of the body. And this is the limbic system. The limbic system, this is the center of the emotions and memory, the gained memory. And it consists of a lot of the centers. These are the fornix, mammalia body, hippocampus, and the excitation every time circulates between these nerve centers in the limbic system and may forms the positive or negative emotions. This is the basal ganglions. In Russian anatomy, it is known striopallid system. In the foreign to us medicine, it is known basal ganglia. The basal ganglia regulate the activity, the movements and the muscle tone. The cerebellum receives the information from the brain stem and may regulate the activity of the muscle contraction and the muscle tone. The other part of this picture is devoted to the regulation of the muscle tone at the level of the spinal cord. You see, this is the example of the skeletal muscle or the muscle fiber, and this is the two ligaments, and they attach to the bone. This is the bone, and it is fixed between the two bones. And the skeletal muscles includes the proprioceptors. This is the special receptors which regulate automatically the muscle tone. This is the two types of these receptors. The muscle spindles, this is the muscle spindle, one example. It consists of the capsule. This is not the nucleus, this is the special capsule. It includes the receptors. And two ends, it is the intrafusal muscle fibers. They contain the actin and myosin, and at some condition they may be contracted like the main skeletal muscles. If the muscle tone decreases, you see the first picture, that's why the length becomes more of the muscle, the muscle spindle stretch out, and the receptor starts to produce the action potentials. This excitation conducts through the spinal ganglions, pseudo-unipolar neuron, and not with the help of the sensitive cortex, sensitive neurons like this, directly stimulates the alpha motor neurons. And the alpha motor neurons conducts this excitation to the skeletal muscles, and immediately they contract and tone start to increase. When the tone increases, the muscle becomes shorter, but the ligaments stretch out, and they stretch out the Golgi organs, the other proprioceptors. This is the Golgi organs. And the excitation conducts, but they don't reach to the alpha motor neurons. First of all, they excites the inhibitory neurons. You see, this is the blue color of the inhibitory neurons. And the inhibitory neurons produces the gamma-aminobutyric acid. This is the inhibitory mediator, and inhibits they inhibit the alpha motor neurons, and the excitation can't conduct the muscle stretch out, and the tone is decreased. That's why every time at any state of the body, at the uprising position, at the sitting position, every time the human beings and the animals have a little bit of the muscle tone. The muscle tone will be disappear only after the death of the neuron or the death of the person of or the animal. At this picture, I present to you the very important line. If we make on the narcotized animal, for example, this is the rat or mouse, we open the skull and make this transaction, and we separate all the brain, this is the brain, from the spinal cord. Immediately will be the spinal shock. What is the symptoms of the spinal shock? 3 symptoms. First of all, this is the reflexia. If we start to stimulate, the excitation can't conduct. Why? Because the excitability of the motor neurons every time depends on the motor cortex and the brain stem. All the other subcortical nuclei stimulates every time at the healthy body the activity, the excitability of the motor neurons. After this cross-section, there appears the reflexia, then the atonia. Atonia means the decrease of the muscle tone, the decrease of the muscle tone, and the paralysis. The animal can't move, but in a time will be the second stage. These motor neurons may work without the voluntary regulation of the brain. It happens in some time. In the mouse and frogs, the second time will be in 3-5 minutes after this cut of the central nervous system between the brain and the spinal cord. In the rats and rabbits, the second period starts in 10-20 minutes. In the dogs and cats, this period will start in some hours, in 2, 3, 4 hours. In the monkey, this period may start in some days, 2-3 days. And if something wrong happens between the brain and the spinal cord in the human beings, the second period will start in minimum 2 weeks and maybe in 2 or 3 months. But you should understand that if we make a cut, the breath rhythm stops immediately, because this is the center, the center of the respiratory center, which regulate the external respiration. But in the frogs and mice, this center is localized in the neck part of the spinal cord. And after this cut, the breathing will be continued in these animals. In other animals and in the human beings, we can't do this cut because the death will be immediately. But something wrong may be with the pyramidal tract. It may be the tumor, the insult or something wrong. And if the brain have no the connection with the alpha motor neuron in some period, very prolonged period in the human beings, will be the second period. The second period, this is the hyperreflexia. Hyperreflexia. We stimulate with the low strength and have the very very strong response. Hypotonia, very strong tone of the muscles, and abnormal movements of the body, because the movements of the extremities will be depend on the work of the neurons in the spinal cord, but not with the voluntary regulation of the brain. This is the presence, the brain stem includes the two types of the reflexes which regulate the muscle tone. This is the static and static kinetic reflexes. Static reflexes ensures the regulation of the muscle tone at the state position without movement of the extremities. And they consist of the anti-gravity reflexes. This is the two examples of the anti-gravity reflexes, and uprising reflexes. And the second, this is the static kinetic reflexes. This is the regulation of the muscle tone during the movement of the body, and this static kinetic reflexes prevents the falling on the ground, on the floor, during the movements of the body. What is the anti-gravity reflexes? This is the automatic reflexes, and the receptors of these reflexes are localized in the proprioceptors of the neck muscles and in the vestibular receptors. If the animal, this example, moves the head downward, immediately the forelimbs in the forelimbs increases the tone of the flexor muscles, and the hind limb in the hind limbs increases the contraction of the extensor muscles. If this is the, for example, this is the cat, it moves the head upward, immediately the forelimbs in the forelimbs increases the tone of the extensor muscles, and the hind limbs are contracted. This is the involuntary regulation. Involuntary regulation without cerebral cortex, and it is very important in the movements in sports. This is the static position of the sportsman before the running, but before the beginning of the run, usually sportsmen moves out their heads and start to run. If the head don't move upward, the sportsmen will flow on the ground. Next, the next picture present to you the this is the somatic reflex arch, but it is continuous to it is finished to the contraction of the skeletal muscle, but at the same time from the sensor neurons the excitation conducts to the sensor cortex through the thalamus. Each reflex arch of the analyzer, this is the sensitive analyzer, includes the three neurons, minimum 4 neurons. The first neuron is localized in the spinal ganglion. This is the sensitive neuron, the second neuron, the third neuron in the thalamus, and fourth neuron in the postcentral gyrus. The sensitive cortex are localized in the different parts of the cortex. This is the visual cortex in the occipital part of the cerebral cortex. This is the acoustic cortex in the temporal part of the acoustic cortex. But this is the specific pathway or limniscus or specific pathway of excitation conduction, the information to the cerebral cortex. But at the same time, the excitation conducts from the limniscus part to the reticular formation. Reticular formation multiply this excitation, and with the help of irradiation or diffusion, the excitation conducts to a lot of the parts of the cerebral cortex, and this reticular formation have the arousal effect. It affects during the daytime and increases the excitation of all parts of the cerebral cortex, the sensitive cortex, associative cortex, and motor cortex. The very strong sound conducts the excitation from the acoustic receptors through, not to the acoustic cortex, but at the same time to a lot of parts of the cerebral cortex. The next picture presents to you the afferent regulation of movements of the body. You see, this is the alpha motor neuron, and it regulates the contraction of the skeletal muscle. The cerebral cortex regulates the activity of the alpha motor neuron. This is the associative cortex. The associative cortex receives the information from the sensor cortex, from the postcentral gyrus, from the visual cortex, from the acoustic cortex. You see, this is the yellow arrows. The associative cortex, this is the main part of the cerebral cortex. 70% of the cerebral cortex, this is the associative part of the cortex. This is the frontal cortex, the temporal cortex, and the other parts of the cortex. And usually the people think that the associative cortex conducts this excitation to the motor cortex directly. No, the associative cortex forms the plan of the further behavior, of the further movement of the body. And this is the principal plan, like a common. And this excitation conducts to the cerebellum, and the cerebellum make the plan more correct, because the cerebellum, it regulates the muscle tone and the contraction of the extremities. After this, the excitation conducts to the thalamus, and after the thalamus, it reaches the precentral gyrus, the motor cortex. With the help of the pyramidal tract, this excitation reaches the alpha motor neuron. This is the voluntary regulation, and the extremity starts to move. At the same time, this voluntary regulation depends on the activity of the basal ganglions. The basal ganglions receive the information from the associated cortex as well, like the cerebellum. At the same time, the basal, the black substances, black substance that is located in the midbrain stimulates the basal ganglia. This stimulation depends, and these neurons of the black substance secretes the very important excitatory mediator, dopamine. And the neurons of the basal ganglia secretes the gamma-aminobutyric acid. This is the inhibitory mediator, and it inhibits the excitation conduction from the cerebellum in the level of the thalamus, but it inhibits not all the information. The excitation decreases a little bit. At the same time, the basal ganglia stimulates inhibits the neurons in the brain stem, and the excitation conduction along the pyramidal tract is decreased. The contraction of the muscles have the more time, but it becomes more precise, not very rapid, but not precise. The basal ganglia and cerebellum have the reciprocal interrelations. The cerebellum every time increases the rate of the muscle contractions and the muscle tone, but the basal ganglions moderates, increases a little bit this rate of the muscle contraction and the muscle tone. And this is the reciprocal interrelation, but they interact at the level of the thalamus, And this is the picture which present the different role of the two hemispheres, the planning and the voluntary regulation of the movements of the body and all the other functions. Usually we draw on our plans in the physiology the brain from the side. This is the frontal picture with the right hemisphere and left one. And the two motor cortex with the help of the pyramidal tract regulates the activity of the alpha motor neurons at the other side of the body. The left hemispheres regulate the right part of the body, and the right hemisphere regulate the left part of the body. They have the different functions. Left hemisphere depends on, first of all, on the motor cortex and regulation of the movements with the dominating right hand. But the right hemisphere depends not on the subdominated motor cortex. The work of the associative cortex depends, first of all, on the sensor cortex, visual cortex, acoustic cortex, sensor cortex, vestibular cortex, smell cortex, and so on. The left hemisphere forms the abstract type of the mentality, the abstract type of the thinking processes, abstract. This is the concrete mentality. The abstract mentality forms the properties of writing, reading, calculation. but the right hemisphere depends on them using abilities, song, and so on. This is the oral memory, the memory with the help of the words, with the text. It have the memory on the base on the words and sentences. This is the imagination memory about the pictures in the around the person, the pictures, and so on. The left hemisphere help the human beings to understand the plans, the graphs. For example, what is the electroencephalogram? What is the electrocardiogram? The plan of the action potential and the change of the excitability. The right hemisphere, it help to understand the point of the person in the surrounding, and it helped to understand where is the washing room, where is the classroom, where is the physiology of the anatomy, the physiology building, and so on. The right hemisphere, it take the information, the previous information, it connects with the past information. All the knowledge, the previous your life, the childhood are located in the right hemisphere. But the left hemisphere, it has the abstract mentality, and it forms the plans of the future. Everybody may to check what hemisphere is prevail. Each person has the prevailing of the left and the right hemisphere. Please cross, intertwine your fingers. Take your both hands and intertwine. The upper arm shows us that this hand is dominated, and make the cross, and that's why the other hemisphere is dominated. Then you make take the position of the Napoleon. Who is Napoleon? Napoleon, this is the French emperor. He lived at the beginning of the 19th century, and he had a lot of the battles, and usually he regulated these battles and stayed on the hill, and with special hat on his head, and they stand at the position with the cross arms this way, cross arms, and the upper arm, this arm show us that this arm is dominated, and the other hemisphere is dominated. Then you may do the applauses this way. The dominated arm is moved, the subdominated stands at one place, and the other part of the dominated hand is dominated. And we have a lot of the tests, a lot of the probes to examine the domination, and not all these tests shows the same result. It may be this that one man has the 9, for example, we do the 10 tests, 9 test shows the left hemisphere is dominated. Only in one case, this is the domination of the right hand, right hemisphere. In the other person shows that in six tests, the left hemisphere is dominated. 4, this is the domination of the right hand. That's why in both these persons, the left hemisphere is dominated. The left hemisphere is dominated. But this domination is more, but this domination a little bit. If you make the applauses this way, you have no domination. 5 to 5. This is no domination. All the hemispheres regulates these processes, and this is no domination. All these processes regulated at the same time. The left and right hemisphere don't regulate these functions separately. They help to each other to reach the purposeful result, to reach the stability of the life and stability of the homeostasis. What is these persons with the domination of the left hemisphere? This is the mathematics, physics, chemists, and this is the painters, songers, the writers, artists, and so on. What is there in medicine? Usually, the medicine, they have no regulation. Both hemispheres are worked at the same time and help to each other to help the patients in the clinic. I want that you send this material to the other students, and put down in your notebooks. You should redraw these plans and repeat and put down around these plans some explanation in words. In this case, you will bring these notebooks at the exam, and you may open these notebooks and may answer with the help of your texts and plans. And I hope it will help you to have a good mark at the exam. Have you a good time. Goodbye. Thank you for your attention. But